Welcome to our machine learning series. Today we will cover a very effective yet straightforward algorithm in supervised learning known as linear regression. Make sure you check out the previous videos to know the fundamentals of machine learning and supervised learning. Now, let's get started. First, let's define linear regression and then understand it using graphics. Linear regression is used to predict the value of a continuous dependent variable based on one or more independent variables. We have covered dependent and independent variables in the previous video on supervised learning. And it is assumed that there is a linear relationship between the dependent and independent variables in linear regression. In simple terms, we can say that linear regression sees how changes in independent variables affect the dependent or target variables. Now, let's understand visually how linear regression works. Here on the graph, the blue dots are data points. The x-axis or blue line represents the independent variable and y-axis or the green line represents the dependent variable. Now, we try to find the line through the data points such that the predictions can be closest to the actual data points. This line goes through the data points, but how do we find if this line is the best? To find the perfect fit, we find the difference between actual data points and data predicted by the line. This difference is called residual and is represented by the orange dotted lines. First, we calculate the sum of squares of all residuals. Then, our algorithm tries to minimize this value by changing the slope and intercept of the line. This means that the most fitted line is found by changing the slope and intercept such that the sum of squares of residuals is minimized. This method is called the least squares method. Linear regression can be used for both simple and multiple linear regression. Simple regression involves only one independent variable. If you remember from your maths class, the equation of a straight line is y is equals to mx plus c. This equation is utilized in linear regression and is represented by the equation y is equals to b0 plus b1x, where y is the dependent variable, x is the independent variable, b1 is the slope, b0 is the y-intercept. Let's see an example to make things clear. See, here we have data on the number of study hours and the corresponding exam scores of students. Here, the score is dependent on study hours and study hours are independent variable. As there is a single independent variable, we will use simple regression. Let's plot it on a graph. Observe the graph and see that the score increases when the number of study hours increase. This is called positive relationship in variables. Whereas, if the dependent variable reduces with an increase in independent variable, it is called negative relationship. Using the least square method discussed earlier, let's assume that we got this line. The slope of this line is 10 and the intercept is 9, resulting in the equation y is equals to 10x plus 9, where y is the score and x is the number of hours. Let's say we want to predict the exam score of a student who studied for 8 hours. We can substitute the value of study hours x into the equation. According to our linear regression model, a student who studied for 8 hours is predicted to score 89 on the exam. Hope this example clarified simple regression for you. Multiple linear regression. Multiple linear regression involves more than one independent variable. For multiple linear regression, the equation would be y is equals to b0 plus b1x1 plus b2x2 so on up till bnxn, where y represents the dependent variable or target variable. x1, x2 till xn represent the independent variables. b0 is the y-intercept or the constant term. b1, b2 up till bn are the coefficients or slopes associated with each independent variable. Let's take an example to make things clear. Here, in this dataset, the number of rooms, size of house, and balcony are independent variables, which are used to predict the rent, which is the dependent or target variable. As there are multiple independent variables, multiple linear regression can be utilized. The equation for multiple regression for this example would be rent is equals to b0 plus b1 into number of rooms plus b2 into size of house plus b3 into balcony. Now, number of rooms, size of house and balcony are the independent variables, hence they are utilized in the right hand side. Linear regression rests upon a few assumptions which need to be followed for it to work. These assumptions are the pillar which support the validity and reliability of linear regression. Linearity. In linearity, we assume that there is a linear relationship between the independent and dependent variables. In other words, the relationship can be represented by a straight line. Independence. In independence, we assume that the observations are independent of each other. This means that the value of one observation should not influence other data points. Homoscedasticity. We assume that the variance of the residuals is constant across all independent variables. In simpler terms, the spread of data points should be consistent across the line. Normality. In normality, we presume that the error terms are normally distributed, which means that the distribution of residuals follow a bell-shaped curve. If you didn't understand most of the assumptions, don't worry, they can seem daunting at first sight. In this video, we covered the basic functioning of linear regression, types of linear regression with examples. We also covered the assumptions that need to be followed for the proper working of linear regression. In the upcoming videos, we will cover other supervised learning algorithms, ML workflow, and data processing. Thank you for watching.